Hello. In this video, we're going to talk about electronegativity and the polarity of bonds. Electronegativity can be defined as the ability of an atom to attract electrons that are bonded to it. Or it could be defined as the ability of an atom to draw or attract shared electrons to it. And as we're talking about shared electrons, we're of course talking about covalent bonding. And so we talked about the different types of bonding. There's ionic and covalent, where covalent arises from the sharing of electrons, and ionic bonding arises from the electrostatic attraction between opposite charges. As is the case in the world, the real world is oftentimes not purely ionic or purely covalent. There's a gray area, so to speak, in between. We could have a pure covalent bond where it's a neutral atom where the electrons are equally shared. In an ionic bond, there's a complete uneven sharing of electrons. In fact, one of those ions has all the electrons holding it together. It's actually opposite charges attracting. Well, somewhere in the middle, we've got what we could call a polar covalent bond, where there's an uneven sharing of electrons. And so there are partial charges on the atoms involved. So electronegativity is a measure of how well the atoms in that bond attract those electrons. And so if we look at the chart that's given of electronegativities, there's some things to observe. First off, let's look at fluorine up in that upper right-hand corner. Fluorine has the highest electronegativity. It's got an electronegativity of 4.0. And so if we look on that row going across that period from lithium to fluorine, lithium's got a low electronegativity, 1.0, fluorine has the highest. So as we go across the periodic table, electronegativity increases. And this is something we would expect. Remember, if we look at the periodic table, metals are to the left on the periodic table. Non-metals are on the right. Non-metals are things that we said that gain electrons, so they're going to attract electrons. Whereas metals, when they make ions, make cations, they get a positive charge by losing electrons, so we would expect them to not greatly attract electrons. And then the other periodic trend that we can look at is that as we go down the periodic table, from fluorine to astatine, for example, electronegativity decreases. And that's true with, for the most part, some of the transition metals, it's sort of not quite completely true, but for the most part, in these other groups or families. As you go down the periodic table, the electronegativity decreases. So those are a couple trends that you want to keep in mind. But a very important fact to remember is that fluorine has the highest electronegativity at 4.0. And so we can use electronegativity to measure, to describe, to quantify the amount of ionic character that's in a bond. And so let's look at something like sodium fluoride, NaF. So sodium, if we look at the periodic table, has an electronegativity of 0.9, and fluorine has electronegativity of 4.0. And so we can look at that difference in electronegativity of that bond. So 4.0 minus 0.9 gives us a difference of electronegativity of 3.1. That little triangle is a Greek capital D or delta, and it means difference. And so there's a little rule of thumb about how we quantify these bonds, that if the difference in electronegativity is greater than or equal to 2.0, it's a pure ionic bond. There's a complete uneven sharing of electrons. If that difference of electronegativity ranges from 0.5 to 2.0, is polar covalent, and that there's an uneven sharing of electrons. If that difference of electronegativity is less than 0.5, it's going to be a nonpolar bond or nonpolar covalent bond. And so if we look at something like a carbon-hydrogen bond, that difference in electronegativity, carbon is 2.5 and hydrogen is 2.1. That difference of electronegativity is only 0.4. So that's a non-polar covalent bond. For all intents and purposes, those electrons are evenly sharing those electrons. Those atoms are evenly sharing those electrons. Whereas if we look at something like fluorine, diatomic molecular fluorine, both of those atoms have electronegativities of 4.0. And so you subtract 4.0 from 4.0, you get 0. So it's a completely even sharing of electrons in molecule like fluorine, diatomic molecular fluorine. And so that's a little bit about electronegativity. It's an important concept that you need to be aware of. Thanks for listening and watching.